Okay, we have a person weighing 490 newtons stands on the scale in the elevator. The reading when the elevator is at rest would be no different from when if you were just standing on the ground. We have a scale inside, we have a guy standing on it, and so it's just going to read 490 newtons. If the force up and the force down are equal to each other, as when it's going at a constant velocity. A constant velocity could be what you're talking about when you're talking about it being at rest in problem 1. There would be absolutely no difference when it's moving at a constant speed. So again, the answer is going to be 490. It's only when the elevator accelerates up or down that there becomes a difference of what's read on the scale. So there's two ways to do this. The first thing was we have 490 newtons is the weight of the person standing on the scale. So that equals his mass times 9.81. So if I want to find his mass, which I would need to do this problem, I divide by 9.81. That equals 49.9. So his mass, we could think of as acceleration. We could solve this problem two ways. We could take the constant acceleration, 9.81, and we could add the acceleration that's taking place in the elevator. In this case, it happens to be a minus 2.2 meters per second squared. So if we did this, this would equal 7.6 meters per second squared. So since we have this new acceleration, what we can do is use that times mass. So to find the force involved, we would take 7.6 meters per second squared and multiply it times the mass of 49.9. When we do that, we find that equals 379.7, or as it says up here, 390 newtons. The other way to solve this problem is to take the 490 newtons and add whatever force is being created by the falling elevator. So what I would do is I would take the 2.2, that's a negative 2.2 meters per second squared, and multiply it times 49.9. This would equal a negative 109.78. I could take the original 490 and add this negative, or subtract it, 109.78. And that would equal 380. So you could break it down either way, or you could solve it like that. Works perfect.